For our next example, we're going to refer to the second problem on the worksheet, and that is we're looking at whether or not rape victims seeking medical attention after their attack is related to their income level. Now, our null hypothesis on these is always we're assuming independence, as we're assuming that a woman is equally likely to seek medical attention regardless of her income level. To test that, we're doing a chi-squared goodness of fit, and the first step before we do anything is always to find our expected values, because once again, we want our expected values to be over 5. When I find my expected values, I copy over my table and I leave the center blank. I only keep the totals. After I've copied my table over, I go ahead and select a cell to start with. I'm going to start with this one right here. And to find it, I go ahead and I take my row total times my column total divided by my overall total. In this case, this will be row total of 49 times column total of 124 divided by overall total of 226. Normally when we do these, we'll go ahead and we'll round it to 2 decimal places. Because this is our first full example, I'm going to go ahead and round to the nearest whole number. When I do that, I get 27. So that'll be 27 right here. Notice right off the bat that what actually happened is there were 30 women in that category, according to my top table. So right away I see there's a difference between what I'd expect if they were independent on the lower table and what I actually got with my data. However, a difference of 3 people doesn't seem like a large one. What we'll do next is we'll go ahead and fill in other numbers we find. I know that I need the total in this row to be 49. If the total in that top row needs to be 49, I can go ahead and take 49 minus 27 to get my cell here, which is 22. Once again, I took 49 minus 27 to get that. Unfortunately, I can't use subtraction to fill in the rest of the table, so I have to go ahead and go back to my formula. For my formula, let's go ahead and look at this one next. If I want to find that, I'll go ahead and take row total, which is 89, multiply by my column total, which is 124, and divide by my overall 226. When I plug all that in and round into the nearest whole number, I'll get 49. Once I've gotten 49 there, I can go ahead and use subtraction to find 40 here, and use subtraction in addition to fill in the rest of my table as well. Now, the reason we fill in our expected values table as our first step is to go ahead and check and make sure we meet our 2 assumptions. That is, I need that whole 10% rule to be met, and what this is telling me is that in reality, 226 women is less than 10% of all the women who are victims of sexual assault. That is, I'm assuming that my population is really large compared to the 226 we surveyed. The next thing I need to do is make sure I'm meeting this 5 count requirement, and that is when I look at my expected cells here, all of these are over 5. Remember, we have some wiggle room here. That is, we can have 20% of our cells to be under 5. In this case, because I have 6 total cells, I could have 1 out of 6. And I could have 1 out of 6 because that's 0.1667 or 16.67%. It would be under the 20% requirement. However, it's better in this case. Once again, I'd like all my cells to be over 5. This is kind of just my tolerance down here. I've met the 10% rule. I have over 5 in each cell. I can go ahead and run a chi-squared on this.